Something I absolutely adore about software is when someone makes something that is functionally useless. And I don't mean, oh, I don't have a use case for it. I mean, there is no grand design, no grand use case behind it. It exists because it exists. It was made because you can. And the IOCCC, or the International Obfuscated C Code Contest, is the pure embodiment of this spirit. The whole point is to write code that is just confusing, that is just awful to look at, but is artistically beautiful and oftentimes tries to solve a use case that literally no one has. And now we have the result of the 29th iteration from 2025. The 2026 version, that'll be out next year. And for this, we have a grand total of 23 winners. Now you might be thinking, how does a contest have 23 winners? Well, the judges like to make up new categories every time they find something interesting. So it's not just like one grand winner here, it's, I think that is cool, that deserves some level of recognition. I'm not going to be going over every single one of them, but I will leave the page linked in the description down below. Be sure to go and check that out for yourself. Also, all of these are being demoed on the Our Favorite Universe channel where the awards were given out, so if you want to go see those run, check that out as well. Anyway, let us start with the IMO award. IMO in this context is not, in my opinion, it is International Math Olympiad. This is a international math competition, and this is an implementation of Problem 5 from 2024. This was a notoriously difficult question, not necessarily because the question itself was that complicated, but the way they framed it, the way they phrased it, was weird and made it way harder than it actually was. Basically, the idea is, given a grid where there is one bomb per row and per column, what is the minimum number of moves you have to make to guarantee a safe path? And the code that turns this into a game that you can play looks like this. This is probably some of the cleaner C code we're gonna see throughout this entire video. Just so you understand what you are getting into here, this is the kind of code you're going to be seeing. Now, even if you understand C, this is still going to be mostly gibberish because it is defining a bunch of new operators that do things they shouldn't be doing. From the author, in the author's test with GCC 15.2.1 and Clang 20.1.8 on ARM64 Linux, as well as GCC 13.3.0 on x86-64 Linux, the code compiles cleanly with these flags, with the addition of these flags here. These two exemptions are due to deliberate choices, i.e. omitting parentheses as much as possible as an obfuscation technique and reducing memory usage as much as possible with built-in C types, because we will be running on constrained 8-bit platforms. The code features several custom operators that extend the C standard. The sleepyhead operator, dash tilde dash, with variants equals tilde dash and dash equals tilde, etc. The fish operator, which sure, and the fishing hook operator, the sword operator, and the Little Prince's rose operator. This is something you'd have to stare at for quite a while to even begin to understand what it is trying to do. But the result of that is this little game here, where you can then go and play out the problem. This is a much smaller scale version of the problem. The actual problem is a grid of 2024 rows and columns. Obviously, won't fit on the screen, but the solution to the problem still works out the exact same way. Next up is the best imaginary emulator. What do we mean by imaginary emulator? Well, the developer for this one included a whole write-up explaining what this is about. The Eternal Software Initiative, an open source technology stack to preserve today's software in runnable form for 1,000 years. Basically, the idea is to create an architecture that is so simple that it can be rebuilt and preserved with very minimal knowledge with something that fits on a singular napkin. We started from the simplest possible target, a computer architecture with one instruction, so minimal that someone 1,000 years from now could re-implement it without any specialized knowledge of our era's technology. Then we built a production-grade LLVM compiler backend that compiles standard C and C++ programs directly to this target with no source modifications required. We ported Linux to run natively on the architecture, giving preserved software the full infrastructure it expects, process management, file systems, and preemptive multitasking. This right here, this is what the code looks like. And with this, you can actually boot Linux off of it. Not just boot Linux off of it, okay? Actually go and run software off of this. And not just any software. Of course, you can play Doom on this architecture as well. On this architecture with a singular instruction. And this isn't some weird fake re-implementation of Doom. This is Doom. Now, it might not run great. Hey, it might run pretty terribly. But it does run. Software, OS, and all dependencies get packaged into a single self-contained capsule, a sequence of numbers that encodes an entire software stack. We provide example capsules with our open source toolchain available on GitHub. Anyone can build capsules from their own software. A reference virtual machine to run capsules is written in C and is less than a page of code. The complete specification is short enough to fit on a napkin so that someone in the future can build a working VM from scratch in under an hour and revive the software inside a capsule. This is absolutely sick. But there is much more to cover. Next, we have the Retro Space Award. This one here is well outside my area of expertise, but is something that was kind of made to appeal to the judges. This is a RPG where you play as Jean-Pierre Luminet in 1978, simulating the first ever photograph of a black hole. What does that even mean? Well, you are going through the same steps that were taken to simulate the first picture of the black hole. The first step takes in a program encoded as whitespace and formats a Fortran program as a deck of punch cards, and those are actually rendered within the game itself. Looking a little something like this, like actually generating virtual punch cards that would have been used to run the software, because back then you did punch card software. The second step takes in a punch card deck, processes its Fortran program, writing any output from the program to stand it out for the program embedded in prog.c. The output is a list of values of observed flux for a grid around a black hole. The third step takes in flux data and writes out a corresponding image as if you were drawing it by stippling on paper with ink. The final step takes the paper negative image from the previous step and creates a positive print of it. This is one of those ones where even if I show you, it's ultimately not going to make any sense unless you're like a giant space nerd. It's basically, as I said, going through those same steps, but simulated. So you are simulating a simulation. Yeah, you're simulating a simulated image of a real process to get a simulated image. I think that makes sense. The code, however, it doesn't. This is the code. What in the world is any of this? What are we looking at here? Unusual encoding formats make tracing data through a program difficult. The program is multifunctional, processing 4 different input file formats. The program is difficult to read because of its layout, and yet its layout is important when passing the source in as the first step. Many standard tricks are used, including some just to reduce the size of the program enough to get all the functionality and data stuffed in. Most variables have multiple uses, sometimes at different parts of iteration through a single loop. Lots of obscure bit twiddling and shifting is used for each each kind of input data. Magic numbers are used in the operator table in the expression function. These numbers encode the precedence level 0 to 6, which operator, and the number of characters needed to advance past the operator in the source. All variable values for the interpreter are stored as complex floats. Punch cards are drawn using strings that are part of the embedded whitespace data, making it difficult to identify the relevant code at first glance. The punch card drawing strings, the Fortran source code, and the PGM header all use the same lookup table string. It may also have a hidden message embedded in it somehow. And this just keeps on going. And this is a nightmare to look at. Let alone the fact that I don't actually know Fortran to even discuss the Fortran parts of it. So let us move on from that one and talk about the best one-liner. This is one that comes up every so often because somebody out there has to write a single line of C code that does something stupid. And this is that single line. What does the line do? Well, if you know what it does, that's impressive. Because you shouldn't. It is a single line implementation of a compression tool. Not just any compression tool. It outputs a compressed file in the same format as the Unix compress tool. You can actually then go and uncompress it using your regular Unix tooling. It does sacrifice a bit of the compression ratio, but it is entirely valid for this program, technically, because this is valid to a version that had a bug in it that you shouldn't be using anyway. But technically, next up is the Consistently Constant Award, which does render a bit weirdly in my terminal because it's doing weird characters you probably shouldn't be using, but you will notice there is a lot of E. Why is there a lot of E? Well, let's see it rendering properly. This is what it should look like. This is a mathematical formula. A formula for E. This goes and outputs the digits of E, but in a weird way. So at the end of it, it also then outputs IOCCC 2026. However, if you output it directly to standard out, you get garbled output. But if you output it through head, if you output it through cat, it's fine. Only directly to standard output is it garbled. Next, we have the Most Resilient Award, and that looks like this. dy over dx. That's bait. Because now it says, and now for something completely different. Do note what looks to be a diff down here. It's in a comment, but it's a diff. What are we looking at here? This is both a patch tool and a diff tool, but not like you can run patch, you can run diff, and just do whatever you want. This is a self-modifying program. Here we have a diff. If you then give that diff into the program, it is going to go and patch the file, and that works totally fine. But then, when it modifies itself, and you recompile it, and then you go and do this another 26 times, then it's going to turn into a diff tool. Yes, I know that doesn't make any sense. The author tries to explain it here. Two tools are woven into one source file, connected by a self-modifying mechanism. The patch tool parses a unified diff from standard in, reads the target file, applies the hunks, and writes the result back. It handles multiple files in a single diff stream. The diff tool, the final program extracted from GitLog, computes the edit distance between two files using ONM dynamic programming, then traces back through the DP table to emit unified diff hunks with context lines. The self-patching mechanism connects the two. Prog.c ends with a valid unified diff targeting itself. When the patch tool applies this diff, it transforms the source into a program that reads its own source via file and carries a stringified copy of the diff engine. A countdown variable t initialized to c-41 equals 26 controls the iteration After each cycle, decrements T and emits one line of the diff program as a subject header in a GitAM compatible email patch. After 25 iterations, T reaches 1 and the program produces no further output. So it is basically using the git log as a way to construct the new program, if that makes any sense. Probably doesn't, so let's move on to the most likely to teleport award. This is thankfully somewhat simpler. This is a roguelike game. And yes, a bunch of obfuscation techniques were used, but the game itself is relatively simple. The reason why I chose this one is, well, it's shaped like a cute little mascot given a thumbs up. This right here is the game itself. Basically, you move around the map, you try to collect the dollar signs, and you also have the ability to teleport. When you press the teleport button, it is going to lower your score by 3 because, well, there are 3 developers. Is that the reason why? I don't know, but it's probably the reason why. And that's basically the game. You go down through the dungeon, collecting points, and try not to die. Next is the Who Won Award. This is shaped like a telephone box, and this is going to output the 1963 Doctor Who intro sequence in ASCII. Now, I don't really have any Doctor Who nostalgia, especially for Doctor Who that old, but I'm sure for people who do, this is kind of neat. Earlier I showed you the best imaginary emulator award. Let's do another emulator, this time the best real emulator award. This one is shaped like a certain Nintendo console. Nintendo, do not sue. This is just some fun. I know you don't like emulators, but at least leave the Game Boy alone. Whilst it's probably not the greatest implementation of all time, it is a totally functional emulator. Here is some custom software that was made, just calculating pi quite slowly because you're doing it in a Game Boy emulator. And here we have a real, actual game running. The ROMs supplied entirely legally. They were not ripped offline. Nope, they didn't come from the internet. Nope, this is a backup of their own game. Definitely. The Game Boy, like the NES, is a very simple piece of hardware. It is a very well understood piece of hardware, and when people often want to write their first emulator, this is one of the things they go with because, well, it's been done so many times. Even so, this is still really cool, and I like the idea of a Game Boy emulator shaped like Game Boy. Next up is the Most Soothing Award. This is a nice, chill one. A nice, basic one that everyone can enjoy.
Like here's another one over here.
We can relax. There are no sharp lines here. There's just fun and relaxation. Just relax.
It starts off with a couple of bubbles, layers them on top of each other.
If the narrators weren't there, it'd be very relaxing.
And then you had this soothing music that comes into on top of it.
Are you calm yet? The sound of ocean waves is, at its core, the sound of countless overlapping bubbles. This program begins with a single bubble and repeatedly synthesizes pairs of sounds, layering them again and again until millions of bubbles accumulate into a wave. The same synthesis operation drives every level of this hierarchy. A single filter function, distinguished only by its arguments, handles everything from bubble resonance and bandpass noise shaping to stereo envelope tracking and musical dynamics. The layers of sound and the layers of reuse converge on the same principle. This is perhaps how the world is also made. Next up, and we can't skip it, the Ping Pong Prize. This is a very weird one. So the source code looks like this. The source code, yeah, it's obfuscated mess, but it's not really that crazy obfuscated mess. But note, what you see in the cutout here, you see a block here, and a block here. Or better yet, you see a paddle, a ball, and a paddle. Because this is an implementation of Pong, but not just an implementation of Pong.
The IOCCC.
It is an implementation of Pong where the game state is the source code. The game takes place in the modified source code, and then when you lose, then it turns into another game, kind of like the Google Chrome, dinosaur bouncing over the things. What? What do you mean the game state is the source code? This is my version of Pong with a killer upgrade. It requires a C compiler to use. Running the program produces the source code to generate the next frame, formatted to display the current frame. By repeatedly compiling and running each successive frame, you can play the game. To move past either W up or E down as an argument, you play as the paddle on the right, and your opponent is the computer. If you don't love the thought of running the same commands over and over again, you can just run try.sh, which automates the process and lets you interact directly using your keyboard. I love this contest, man. I really love this contest because no sane person would ever think that you should do this. And the final one I want to show you, the most magical word. Now, if you know what this means, you know where we are going with this. This is shaped like Fern from Freeren. There's always gotta be one. There's always gotta be at least one weeb that makes their way in. A skilled mage only needs one magic to defeat most foes, and that's the ordinary offensive magic, also known as Zoltarak. Inspired by the simplicity and versatility of this magic, we have created a language that contains just Zoltarak. No operators or operands or other complications, just Zoltarak. Here is a sample program that outputs 216 plus characters. Zoltarak. In 27 lines of code, 9 lines of Zoltarak plus 18 blank lines. We managed to produce more bytes of output than we put in. We still need a way to turn this code into an executable, and writing all these lines is rather tedious for large programs. This IOCCC entry, henceforth called Fern, solves both problems. Simply feed the desired text through standard in, and Fern will produce C code on standard out. Output C code starts with a few lines to define Zoltarak, followed by a mix of Zoltarak and blank lines. Output is slightly compressed such that it's possible to get smaller than the original input depending on the amount of redundancy present. Obviously, we can achieve a higher compression ratio if we choose a shorter symbol than Zoltarak. To use the more compact version of Zoltarak, compile Fern with a C++ compiler. Effectively, this is like white space language. This is like, it's one of these like fake programming, dumb programming languages. Instead, in this case, we're just using Zoltarak. And you know what? I think it's cool. I think everything we've seen here is cool. I don't know if you guys agree. If you don't, hey, let me know down below. And if you do agree, or maybe there's another one that I didn't cover you think is cooler, let me know in the description, in the comments down below. Tell me your favorite, tell me what you liked, and tell me what you didn't like. Anyway, if you liked the video, go like the video, go subscribe as well, and if you really like the video and you want to become one of these amazing people over here, check out the Patreon, Scribes, Daily Bearer Pay, linked in the description down below. That's gonna be it for me, and just stop. Just stop.
Something like this.